Torill, thanks very much for joining us. Obviously, a lot of focus at the moment on ESG, and particularly carbon reduction. What are some of the practical things that people can actually do and should be doing?
So the environmental part of an ESG does focus on the carbon emissions and how they can be reduced. An important element of carbon emissions is in the embodied carbon, so in the materials used. And about 30% of a construction job would in fact be in the embodied carbon. So practical things that you can do are to consider your materials that you're using, the source of those materials. So what countries are those materials being manufactured in? Because the emissions are emitted where they're made, not where you're using them. So you'll be looking at countries with high coal use in their energy production and comparing it, for example, to obtaining your materials where the energy mix is a larger amount of renewables. So sourced from Europe rather than from Asia, for example, and you're going to be looking at a lower carbon footprint for the same material.
And there's a lot of discussion around, modern methods of construction, but also, I suppose, more carbon-friendly concrete, different structures like that. How important are those, do you think, Torill, in terms of being able to support the kind of drive towards carbon neutrality?
So concrete can be a very carbon-heavy material, but there are lots of different formulas of concrete, lots of different mixes, whereby you can reduce the carbon emissions for the concrete itself. So if you're able to reduce the amount of CEM1 in your concrete mix and replace it with a low carbon item, then you might have to arrange your building plan around the fact that may take longer to harden, but you'll be reducing your overall carbon footprint. So I think taking the carbon into account when you're considering what you're building with, as well as what we currently take into account, so we've got cost and time, but cost, time and carbon. And once the carbon emissions are spent for something like a building, that's it. It's set forever. So that construction, considering it upfront, is a really important step in lowering your carbon footprint.
How much of a focus should there be, do you think, Torill, on the operational side?
Yeah, of course. You're designing a building from scratch, or you're refitting a building. There's two things you want to take into account. So on the embodied carbon side, you want to build your building with reuse and repurposing in mind from the beginning. So reusing and repurposing has to be our future. We have to be able to treat our constructed buildings that we have now as material stores of the future, so that we can take those materials and use them again, and building it with low energy use in mind. So we're talking about better U values for the materials, better insulation, fitting heating, for example, that is not based on fossil fuels. So you might want to make sure you allow room for a ground source heat pump, so that you don't need to rely on an air source heat pump. So thinking about these things up front and building in future ability, because at some point in the future, a new technology will come along that will be carbon friendly, and you want to be able to incorporate the new technology into your building.
Once the building is in operation, you've got issues to deal with, like maintenance. I suppose, what's the role there, and can that have a role in carbon reduction?
Absolutely, yes. And I think it's an overlooked role, in fact. So if you incorporate your thinking around carbon into your maintenance strategy as well, and you use, for example, a dynamic maintenance strategy as opposed to a reactive maintenance strategy, or even a planned maintenance strategy. Dynamic maintenance means that you follow the performance of your assets with the data on those assets. So if you build in the ability to have telemetry on your assets, which is common because they're often used for alarm signals, but build in with your telemetry the ability to monitor that data rather than just when it reaches an alarm, so that you can intervene at the point at which a greater amount of energy is being used. So if energy is starting to be lost through friction or heat as the equipment starts to run less efficiently, you can intervene then. And not only are you maintaining your asset, but you are reducing your carbon footprint because you're not wasting energy that is, of course, carbon. So those interventions will reduce your downtime, keep your assets running. So you've got serviceable assets, you're increasing your serviceability, and you can make better use of your maintenance resource as well. You'll use less spares. You can use your human resource better because you can plan their time and their travel around assets that they're maintaining better, because you can plan in their visits according to the telemetry data, the operational data that you're basing your dynamic maintenance on.
Really interesting to get these kinds of insights, I think, from the engineering perspective, and those sort of more practical ways that people can actually make a difference there. Thanks very much for joining us, Torill.
You're very welcome.